Hey everyone, my name's Rowan, and today I'm going to show you how I would run a threat modeling session. And I'm going to do this based on an Azure architecture example I've come up with for this. Now, first things first, what is threat modeling? So threat modeling is pretty much what it sounds like in the name. It's where you come up with a model, typically in a diagram format, of all the vulnerabilities that could possibly be in your whole system. This is a really important process to follow because it helps identify not all, but let's say a lot of the vulnerabilities that could pop up in your application and in the platform that it lives on. The strengths of this process really shine when you do this as a group and get the whole dev team involved. Not only does it help cover a wider scope and let everyone contribute to make sure that nothing's missed, but it also starts getting all of your team members thinking about security themselves, taking a bit of ownership of it, and then eventually they'll start thinking about it in their day-to-day work. So these are the steps we're going to follow as a team. We're going to start by mapping out the architecture of our system. We're going to highlight threats following the STRIDE model, and I'll show you that in a minute. We're going to map the STRIDE threats to the OWASP top 10. We'll go through that in a bit as well if you haven't heard of that before. We're going to highlight the solutions to our problems, and we're going to record any improvements we need to make to our system. So we're going to start off by going to a diagramming tool. I'm using this, it's called Miro. Really anything you're comfortable with is good. Anything that lets you just draw sort of diagrams, flowchart kind of things. Microsoft happily provide a load of icons for us in a huge downloadable file, so I'll share a link to that. The user one I did just pull from Google. Up here we've got the STRIDE model. So what STRIDE is, as you can see from the things down the side here, is an acronym, and it's a model actually developed by Microsoft quite a few years back that helps you think about your threats in terms of these individual elements. So we've got spoofing, tampering, repudiation, basically not having traceability in what's going on, information disclosure, denial of service, elevation of privilege. I'll put a link to this in the description as well. Not only has it got the threat and the definition, but it's also sort of got some examples which can be helpful for your team to follow along, particularly if they're not used to identifying security threats and they're not used to this sort of process. So with these resources I've got here, these are some things that I've highlighted that I think are going to be part of the diagram. I've put these together to make the whole thing easier, but it's very important that I didn't just create the diagram myself for the team to look at and sort of discuss the vulnerabilities. It's really important to get the perspective of everyone involved so this whole process spreads this ownership of security. So what these elements are highlighting the users to your system, the modules or nodes to your diagram. So this is kind of like all of these sort of things here, the different elements, the different resources in your Azure setup. And then we've got the links between these things, which is the different methods of communication between the services, the different protocols. Sometimes the format of the data as well can be useful. And the last thing you'll have are trusted boundaries. These are basically boundaries representing trust between certain elements, like a VNet or maybe a firewall. So we're going to take stuff from here, and the easiest thing to do is start with a user. Now, the example I'm thinking about for this is going to be a little chunk of an online video game. So our user is going to be a player, and the first thing that they're going to take is a client application, basically a .NET sort of local client or game client. And before I draw any links, let's just flesh out the diagram a little bit more. So we're also going to have a container instance, and let's just call this game server for now. So we've got our three elements here, and now what we can do is start drawing the links between them. So here we've got the player, we've got the client, and this is an Azure container instance. This is just representing game server, but the way I want to break this down personally is in this instance, in the one I've got in my head, we have a container instance which contains lots of different endpoints for our game server. Each of those endpoints behind the scenes are going to be doing their own things. They're going to be accessed with different roles. They're going to be calling different external services. So I like to represent these as their own nodes just by taking these. And for the example, we're just going to have two example endpoints. Now I'm going to add a boundary in for these to show that they're sort of linked together in one thing. It's not necessarily the typical way you would show a boundary, but I think it really helps highlight that these are all part of the same service. Something else we've got is an update service, but it doesn't live as part of this game server. So we're going to put it in its own thing, but it's going to live separately. For the sake of this, I want them to all have the same sort of level of trust. I'm going to have everything managed between these services as a VNet. We're going to fit a container registry in here. And both of these APIs are probably going to need some kind of storage. And now, not everything necessarily is all going to live in a big trusted virtual network like this. So in this example, I'm also going to have a function app for my login service, and the login service on the back end is going to talk to Azure Active Directory. So For this example, this is what I'm going to worry about in terms of arrows. So this is our architecture diagram. So we've got all of these things set up. Now we're going to think about how these interact with each other. So the way the player interacts with the game client is literally just going to be manually. Actually, I'm going to notate these a little bit different just to help distinguish it between the labels. So the game client to the server. Now, this is actually going to be done in a couple of different ways. I'm going to move my arrow straight to the game server, and I'm also going to take another arrow and put it to the update service separately. And I'm doing this because I want to highlight, possibly need some more space there, but for now we'll make do. I want to highlight that the game server is going to be talked to through UDP, and the update service is going to be talked to through HTTPS TCP. The reason I've highlighted TCP here is because this is specifically UDP. You don't need to go and say, TCP for all your HTTP stuff. And for the login service, just for the example to spice it up, let's have a service bus. And this could actually live as its own module as well. It is a resource. And the last thing we've got here, the way I'm going to denote this connection is as OAuth. Again, this I guess doesn't really necessarily represent the transfer protocol, but I'm doing what works for me and what makes the most sense. So now that we've got all these things, let's take each part individually and see where we can map security elements from the Stride model to these things. What issues could we have between the game client and the service, and the service and Azure Active Directory? So if we look through this list and try and identify what we think could be going on. Spoofing, not necessarily in this. I mean, this is the authentication. This is proving that this is sort of doing the authentication itself. So I guess you can't really spoof that at this point. Could you tamper with the code? You could possibly tamper with the code. Have you got traceability over it? Could you claim it did or didn't do it? Yes, you absolutely could have that as a problem. Information disclosure? Probably not so much. This is login data. It's going to kind of be part of some of this other stuff. It's not really any personal information or anything specific. Denial of service, that could absolutely be a thing. You could try and hit the login server with as much as you want. Elevation of privilege. This isn't really going to be a thing unless maybe you have admins logging in the client in a specific way and the client behaving different depending on what privileges you have. But for this, we'll say, well, let's just say that it's not. So we're going to take tampering, repudiation, and denial of service. Put another boundary of trust in here, because these are all on the same side. But we could say these things are going to talk to each other. They're going to authenticate with a service principal. You could talk to Azure Active Directory externally without the login service, I guess. So in terms of that, let's think back on our Stride model. If you were trying to connect to Azure Active Directory externally, what do we have in process? Spoofing, pretend to be someone else? No, yes, you can, because we've got this idea. And in fact, maybe I'll even add it in here. That's not necessarily a way you connect. It's whatever works for you. This maybe is starting to get a little bit clustered in what it's trying to represent. Let's just go with this. And in terms of service principle, well, you could have spoofing. You could try and pretend to be someone else. Whatever you feel represents the actual threats in your system. It's always good to go overboard here than underboard. So now we have this diagram set up. We've got different examples. We've done a few bits in a few places. It's not a whole example. We've done some of the Stride in some places. It's just to get an example. So the OWASP Top 10, if you haven't heard of it, it represents a general list of the sort of most critical security risks to web applications. So we've got our Stride parts, and we can map onto these 10 different things here. If you go into one of these, the descriptions start giving you different examples, and it's very good. These examples are very good as a baseline on what this aspect, this broken access control in this case, takes the form of. So by looking at these, we can start identifying where in our threat model, based on the Stride, some of these things apply to them. So if we take something like this first connection here, where we've got tampering. So which of the OWASP top 10 can we map to tampering? Which is specifically changing the data or the code that's sent to the server. So broken access control sounds like maybe it could, because you could change the access you're sending to the server potentially. Cryptographic failures. So this is actually to do with, is your data secured? Is it exposed? And I think that's definitely a thing. You need to make sure that the data you're sending up to the login service is encrypted. Injection. You could inject data into the request itself. That's definitely a thing. So vulnerable and outdated components is the next one. So this is a case where it doesn't necessarily live on the transfer, the connection itself. This might live on an actual resource. The login service is hosted by Azure, and Azure Active Directory is as well. These are all kept up to date pretty much by Azure. You don't necessarily have to worry about, like, say, third-party applications, because it's all handled by them for you. The game client itself, however, that could very much be affected by outdated components, libraries that are old, have got publicly known bugs in them. So we're going to take that one and we're going to apply that in a second, specifically to our client. Software and data integrity failures. So where we've got the outdated components bit being sort of old, wrong versions, this is verifying the actual request location, or where you're getting updates, services, all that kind of thing from, to make sure it's from a legitimate place. So again, to me, this kind of fits more with the actual client rather than the way that we talk to these things. Security logging and monitoring failures. So here is where we want to capture, are things going on properly? When you request to connect and something seems malicious, are you logging it? Are you logging all login requests anyway? Is something you want to log? And this probably, to me, actually lives on the login service itself rather than the connection or the game client. So now we've got something we can start putting on this service. So the last thing on our list is server-side request forgery. If we go into this, what I'm thinking in this case is, in terms of our project, if you're able to tell the game client to somehow use a different login service than ours here, then it could do its own verification and say, yes, you're good to go. As I get to the end of the list here, I realise actually I've kind of covered the T, the R, and the D all in one go here. I still think it's really important to highlight these as separate, so we can go and say, okay, we were first looking at tampering, but for repudiation and denial of service, have we thought about these different things? So repudiation, we did sort of mention some of the login stuff. Denial of service, if we go back here, I would say it's going to be more a security misconfiguration than anything else. So I've got these different parts, and we're going to actually sort of list these things. Now, I don't obviously want to go and put all these OWASP top 10 things all over this diagram, which is also already getting pretty full. So I'm going to start by putting these circles all over the place, and I'm going to use these to map against a little graph we're going to use at the side, or a little table. And these are going to be all over this whole thing. Each element that we do this for is going to have its own number. And so over here, we're just going to have this table. We only need 2 columns. We're going to have area and OWASP. So the area is going to be these 3 points over here. And here we're going to have the OWASP things, and these are directly going to relate to the specific things like AO1, AO2. So if we take the things we talked about before, and we could just put them back into the graph here. In fact, actually, it probably would have made sense to do that in the first place. So if you're doing this yourself, yeah, you won't lose track of the things we've talked about in the list if you're doing this at that point. So I filled these in, and actually, as I went back over it and looked at it, I decided to move some of these things around a bit so that they fit better with the specific elements we've got. So we've got the nodes, and we've got the communication, and the communication itself, in this case, I'm kind of taking into account the fact that the service bus is a resource itself. More specifically here in terms of this AO5, which is the security misconfiguration, because the configuration of the service bus could be part of this. So now that we've got all these different things mapped out, we can go to each one of these. So let's take one as an example. Let's do the cryptographic failures one. So we can look through these and try and identify how we could prevent the problem here around our data being encrypted. Now, you might already know how you want to do this, in which case you don't necessarily have to look through these. These are kind of like examples if you don't know what you're doing. So when thinking about encrypting our data, we've got, like, as it says here, like HTTPS or TLS, and in this case you can enforce TLS on your queues. So specifically because we've got a service bus queue here, that's what we could take to ensure that the data is encrypted. So out of this, actually, what we probably want to do is either make another column or possibly even another document in this case, you kind of want to report. Some threat modeling tools actually can help generate reports for you on sort of your outcomes. I haven't found a threat modeling tool I like enough myself to do over something like this, especially because this is a piece of software that my team uses often, so no one has to learn a new tool to use this. So I like actually recording my outcomes for this just in like a Word document. When I say Word, I mean Google Documents. And so what we could just do here is I'm going to have area component and solution, because I want to highlight, as this is a completely separate report, what the area is linking back to here. The component is the Azure Service Bus, and the solution I'm going to have here is Azure TLS minimum version. And so, yeah, we just want to really go through each of these areas, each of the different parts on them, look through the list of preventions, or come up with your own preventions, and make sure that everything is covered. There we go.